Okie dokie. How's the transmission? Can everybody hear me? Am I audible? Test 1 2, test 1 2. Okay, I'm audible, which is amazing. Let me turn on my camera. And welcome everybody to today's webinar, Introduction to Compass. As always, as you're used of us, we're using the Zoom conference, and that means that the first thing that we'll do is look at the Zoom conference system and how to use it in order for you to ask questions. So I'm audible, I pressed record, we're live. Awesome, we're in a good place to start. So I'm going to share my screen. Share my screen. There we go. This is the guy that I want to share. Okay, and let's hit play. So as I said, welcome to today's webinar, Introduction to Compass. We're using the Zoom platform, so let's start by looking at the Zoom platform first. In front of you, you are expected to have a window, not unlike the one you see over here. And if you want to ask a question, we encourage you to use the chat feature. And in order to activate the chat feature, just simply click on that balloon, which will open a dialog to the right-hand side. In the bottom, you can enter a message, you can address the nation. However, should you see a fellow colleague, family member, or friend in the list of participants, then you can also address a personal meeting to that person only. If you want to ask a question, I encourage you to make use of the raise hand feature. If you click raise hand, then I know that you want to ask a question. It pops up to my left, and that means that I will find a white space in my narrative and try to address your question, answer your question to the best of my ability. Some of you will be watching us through Zoom, but some of you will also be watching us through the Meyer user community, as we're currently streaming live. And the Meyer user community counts currently over 8,000 members, so this is another place besides Zoom where you can watch today's webinar. Okay, that pretty much concludes household notes, and that means that we're going to look at Compass. 2 webinars ago, we talked about the Meyer Precision Toolset, which are the pillars of our workflow, design, monitoring, managing loudspeaker system, but also immersive sound and spatial sound, as we discovered, and ultimately even the distribution of audio, power, and RMS signals. Last webinar, we looked at an introduction to MapXT, which is the first pillar within the toolset, besides the loudspeakers, which are of course at the heart of it all. And today we will be looking at Compass, which is a tab-based control software that we use to control our galaxies, among others. So what is Compass? And what do I want to discuss today? Well, here we have the checklist. I have my pen ready to make sure that I don't skip anything. So we're going to talk about what is Compass, how do I register to the website so that I can download the software, a little information about the Galileo Galaxy devices, audio signal flow, how to get connected, window display options such as zoom and full screen, how do I name my Galaxy device in a way that makes sense to me, how do we label our in and outputs, how do I select my inputs because there are several to choose from, a little bit about metering, and then how do I process my inputs using parametric EQ and such, summing and delay matrix, very powerful summing and delay matrix, modifier keys which expedite the workflow, output signal processing, and then how do I store all of that in snapshots with so-called recall save options, and how do I make one of those snapshots bootable. We're all going to discuss that. We want to save projects, and I will leave you with telling you where all your folders and files live depending on your operating system. And then finally, there's the right-click menu, which also unlocks a subset of all control points that we have to choose from, or that we can choose from. We don't have to do anything. Okay, so what is Compass? It's a comprehensive and intuitive way to control all features and power offered by Galileo Galaxy devices, including the Cal column array loudspeaker. We have an entire week scheduled on Cal, so rest assured we will inform you very well about column array loudspeakers. That being said, the Compass software can also integrate with RM server, as we saw already during the introduction to the toolset, the precision toolset, and that allows us to monitor the health and status of a twisted pair connected loudspeaker or power supplies that are equipped with an RMS module. It's a tab-based graphical user interface. On the right-hand side, you can already see several tabs. So it's a tab-based user interface, which allows us to simultaneously support multiple Galaxy devices, as well as Cal loudspeakers, as well as RM servers. It manages snapshots both locally as well as globally, so it also allows us to manage snapshots and projects among multiple Galaxy devices, as we saw during Oscar Barriento's Compass A Global View webinar, which you will find on our YouTube channel. And finally, it offers the opportunity to make all sorts of user-defined control groups and pages that allow us to control multiple Galaxies, multiple loudspeakers living on multiple Galaxies with a click of a few buttons. So that is in a nutshell what is Compass. Now, if I want to download Compass, I first need to register to the Meyer Sound website. So let's take some time going through that process. First step is, of course, go to the website, visit meyersound.com. Once you've browsed successfully to the website, please click register in the top right corner, which will take you to a form. A form speaks for itself. All questions with a red star, an asterisk as we call it, you are required to answer. And once you've successfully completed the form, you are going to get a confirmation email telling you that you did everything the way you're supposed to. All is fine, all is good. Once you've received your mail, now we can log in to the actual website. So in order to download the Compass software, now that I've successfully registered to a website, we visit meyersound.com once more, and in that same top right corner where we previously registered, next to it is a button which says Login. If you click on the Login button, a window pops up asking you for your username, your credentials, and your password. Once you have successfully logged into the website, all that's left to do is to go to the Products tab. And once you go to the Products tab, it takes you to a list of all products. And if you scroll down that list until you see Compass, you want to click on Compass, which takes you to the Compass product page. There's 3 tabs to choose from: Overview, which is an introduction to what is Compass. Then there's a software tab, and there's a support video tab. Speaks for itself that you want to click on the software tab. And if you click on the software tab, it takes you to this page, and there you can download the latest version of Compass for both macOS and Windows. So that is the way to download the software. And let's assume that you've successfully done so. That means that we can start looking at the Galaxy devices that we control using the Compass control software. So this is going to be a brief rehearsal of what we already saw during the introduction to the toolset webinar, because what are Galaxy devices? Well, Galaxy devices are primarily used as a loudspeaker management system for both calibration, also referred to as tuning, as well as voicing, also known as toning. It's AVB based and Milan certified, and it has several proprietary processing techniques such as U-shaping, which is you can think of that as multi-band EQ, as we're about to discover, but it has some extra bells and whistles. A product integration, which we already discussed during a previous webinar, where we explain how do I make all these loudspeakers from different phase curve families play nice with each other by giving them the same phase curve. LMBC, which is our proprietary low-mid beam control, which we will dedicate future webinars on. Then there is the option, as I already mentioned, to locally and globally store snapshots as well as projects. It has a vast summing matrix, 32 inputs by 16 outputs, both level and delays we're about to discover, which paved the way, which made it possible to support SpaceMap Go, which is soon to be released, which allows for immersive sound and spatial mixing. We can link multiple Galaxy devices locally as well as globally. Locally would mean linking multiple outputs or multiple inputs together, but we can also do so globally across multiple Galaxy devices. And all of these Galaxy devices support multiple clients. Today we will be focusing primarily on Compass control software, but as we already discovered during previous webinar, there is the Compass Go, and there is in the foreseeable future there is the SpaceMap Go. Now all of these Galaxy devices come basically in three flavors. There's the so-called 408, there's the 816 AES3, which I will be using today, and then there's the Galaxy 816. And the main differences are primarily I/O capabilities. So here we see the front and rear panels of each of these devices, and as you can see, judging by the number of input and output XLR connectors, it's primarily a difference in I/O capability. So let's look at that a little bit more in depth. The first model in the Galaxy device platform is the 408, and it's called 408 because, as you can see, it has 4 input connectors and it has 8 output connectors. 4 analog input connectors within the pink bounding box, and 2 of those double as AES3 inputs. Now, I would like to remind you that a AES3 format is dual channels, so these are AES stereo inputs, if you will, for lack of a better description, which is the reason that there's only 2 and not 4. So 4 analog inputs and or 2 stereo AES3 inputs. Other than that, it has 8 analog outputs. Within the blue bounding box, we see our primary and secondary AVB inputs, which allow for additional input capability. So how does the 408 differ from the 816? Well, as you can see, the 816 has twice as many inputs and twice as many outputs. So there's 8 analog inputs to choose from, and 4 of those double again as AES3 digital inputs. And we have 16 analog outputs instead of 8. And finally, the flagship model, which is the A16 AES3. It has the same input section as the 816, but it has digital outputs besides analog outputs as well. Where the 816 only has analog outputs, the AES3 version has 8 analog outputs, which live on connector 9 through 16, and in addition, it has 8 AES3 outputs. Remind you, each of those are 2 channels, dual channels, so I have 16 digital outputs living on 8 physical connectors. And finally, the 816 AES3 for timing critical applications also has a BNC word clock connector. So those are the basic differences in terms of physical connections on the rear panel. That being said, regardless of the number of processed inputs, all models allow you to feed an additional 24 inputs directly into the matrix via AVB. And that means that independent of your model, you will have at all times 32 total inputs. 24 of those are AVB inputs directly fed to the matrix, and the remainder 8 inputs is a combination of either analog, digital, or additional AVB inputs. That being said, as far as output capability is concerned, all of them have 16 outputs, also made possible by AVB, not necessarily in terms of physical connectors for XLRs, but in terms of AVB capability, there are 16 outputs. And that means that each of these devices does support a 32 by 16 matrix, that is to say 32 inputs and 16 outputs, which makes it possible to run SpaceMap Go on each of these devices, but we'll save that for another webinar. So that's a brief introduction to Galaxy devices. We're going to use Compass to control these devices, and that means that I think it's prudent to briefly look at the signal flow. Now I'm going to focus on an 816 AES3 example, but if you understand the AES3 example, then surely you will be able to appreciate that the 408 and the 816 work essentially the same. So let's read this chart left to right. Starting on the left side, we have our Galaxy inputs, which are 32 unique audio inputs. 24 of those are AVB, and the remainder 8 can be either AES3 or analog. Next block in my signal flow is the ingress point. This is basically my input source select. This is where I assign any of those inputs to the 8 processed inputs that we have available within a Galaxy platform. So that's where I assign the physical inputs to the input signal processing 8 channels of input signal processing, labeled A through H, as we're about to discover. So there you have your second and third block in the signal flow. From there, we can already start splicing off signals towards AVB. If you have a larger ecosystem containing multiple Galaxy devices, but that's beyond the scope of today. This is an introduction. So let's continue our flow chart. Next up is the so-called summing and delay matrix. And the summing matrix is basically where we connect physical inputs to physical outputs. And we can set a level at those cross points, as they're known, where physical input meets the physical output. We can set a level, but as of Galaxy, we can also set a time offset, which gives a very impressive performance capabilities that made something like SpaceMap Go possible. Once we've linked our inputs and outputs, the outputs can be further processed using parametric EQ, U-shaping, high-pass, low-pass filter, as we're about to discover. And then finally we go to the physical outputs on the back of the Galaxy devices. Or splice off, we tap those audio signals and send them over AVB outputs, which we'll discuss at greater length during future webinars. So that is in a nutshell the signal flow within a Galaxy device, and it's the same for an 816 or 408, except that the 408 has fewer physical and inputs and outputs, as we already discussed previously. So that is our audio signal flow. Now, I'm going to assume that we've successfully downloaded the software, as I showed you before, and installed the software, and that means that the next thing is, how do I get connected? How do I connect my computer running the Compass control software? How do I connect it to the Galaxy device of my choosing? Well, that's a very straightforward process because Galaxy devices support IPv6, which means that if I have a Cat5e or better network cable, all that's needed is directly connect my computer to the Galaxy device. Switches are not mandatory at this stage. Directly connect to the Galaxy device, and IPv6 will make it possible that further steps are unexpected. Further steps are not mandatory. That being said, if your ecosystem for whatever reason does not support IPv6, then Galaxy is smart enough that it will default to IPv4 rather than IPv6. But in terms of connection, network cable is all that you need, and then you can connect either to the primary or secondary network port on the back of a Galaxy device. Okay, so we've connected to our Galaxy. I have an 816 AES3 living over here, which is the model. It's the model that we see over here, which is the one in the middle, which has the AES outputs as well as analog outputs. I've got one of that unit living to my right next to my desk, and let's see if we can find it and can connect to it. So I'm going to start up Compass, and let's wait for it to start. So there we have Compass. I'm going to make it full screen, as you're used to do with your internet browser or any other application. And this is the default page that Compass will start up with. And we can also see it because we are currently, by design, in the Compass preferences. And notice that over here it says, what is the default tab that Compass should start up to? And by default it's set to the Compass preferences tab, and that is the reason why we start in this particular window. Now there's a lot to see, and we're not going to cover all of it, but several things are worth pointing out. For example, this looks rather small on my particular display. Is there a way that we can make that larger or smaller? And the answer is yes, there is. In the top left corner, we see the Meyer Sound logo. And if I click on the Meyer Sound logo, then it says Window Display Options. And by clicking on Window Display Options, I can either go full screen or change the size of my Compass graphical user interface to meet my application. So if I were to set this to 150%, then you see that everything becomes smaller. Whereas if I were to set this to something like 50%, then it becomes unreadable, at least to me. So let's make this a little bit larger so that everybody can see the fine print. So that's the first topic on the list, which is how do I change the size of my graphical user interface. You can also see that there's another drop-down menu over here, which gives you the same functionality, except that this drop-down menu only lives on this particular tab, which is the Compass preferences, whereas this Meyer Sound logo, the window display options in the top left corner, you will see throughout the graphical user interface. So you can always access that functionality at your discretion. Another thing might worth pointing out at this point is for those that work in challenging lighting conditions, over here we can choose between two different skins, if you will. By default it goes to the night color mode, which means that you're always working against a dark background, which is convenient when you're working indoors and do not want to blind somebody. But we all know that if you work outside, you'd rather might have something which has a light background, and for that you would choose the day option. So there you choose between night and day. I'm going to go back to the default setting and leave that for now. Okay, so check. The next thing that I want to do is figure out can I connect to my Galaxy device, because I've used my Cat5e Ethernet cable directly connected to the processor, and that means that if we go to the processor's tab, that it takes us to our inventory. And the inventory is currently empty because we're just starting up Compass. And the next logical step would be to ask Compass to start finding devices. After all, we've physically connected our computer to the Galaxy device, and let's see whether it will find my Galaxy AES version. So I'm going to click Find Devices, and there you go. So here we see one entire Galaxy device with everything that there's to learn about it. It shows me the name of my entity. If it's part of a group, it will show it in this column. It will show me the name as it is about to appear in the graphical user interface. So the name that we see over here is also the name that you're going to end up seeing in that particular tab. That's one of the first things that we're going to address. It shows me the device type, whether I'm using a 408, an 816, or an 816 AES3, which firmware it's running is shown, whether it's available, and then I have two options. I can either connect to this physical unit or I can use it as a virtual unit, where virtual speaks for itself, gives you all the same functionality except that you're working on a virtual Galaxy rather than a physical Galaxy. We'll discuss that during the course of the webinar. So I'm happy with this. We found our Galaxy, and all for me that's left to do is connect to this Galaxy, and notice that the connection has now changed to it shows disconnected, which implies that you are successfully connected. If for whatever reason I want to disconnect my connection, I simply click disconnect. Your project and active snapshot have not been saved. Are you sure that you want to disconnect? Sure, let's disconnect because we haven't done anything so far. So there we can connect and disconnect to our Galaxy device. Notice also that there's a color change in the tab. If we're not connected, then this tab is gray, telling us that we're not connected, whereas if we are successfully connected, then it colors blue. So let's go to this particular Galaxy tab. By default, it goes immediately to the overview, which is your bird's eye perspective. It shows you basically everything that you want to know out of the gate, but we'll look at the specifics during the course of this webinar. The first thing that I want to do is label this galaxy in such a way which makes sense to me, because for all I know on a given day I might be working anywhere with 4, 5, 6 galaxies, and labeling them properly would be prudent. So in order to do that, we're going to abandon the Overview tab and we're going to go to the Settings tab. And in the Settings tab, there's a lot of information to see. Okay, once more, we're in the Settings tab, we're in the Network page, and once more I can see what kind of device that I'm using, what its current name is, if it's part of a group, which also matters for AVB as we're about to discover in the future, what its serial number is. And notice that here we also have all the network information. There's 2 discrete Ethernet ports, which each have their unique IPv6 address, as well as an IP4 address. This is also where you would update firmware and such, but we'll save that for another day. The features that I want to focus on is changing the name of this entity, because the name that lives in this box is also the name that we see over there. So why don't I call that today My Galaxy? Okay, I'm going to call that My Galaxy. I'm going to press enter, and then that will read My Galaxy from here on. This now reads My Galaxy, and so does the top over here, and that tells me that this is the galaxy that I'm looking at. Furthermore, you will notice that there's an identify button living over here. And that is very convenient, because if I click this identify button, then as long as it's blinking, the front LCD panel on the physical Galaxy device goes from blue to green, from blue to green, from blue to green. So as long as this is blinking, you can visually, cosmetically identify, am I connected to the physical Galaxy device that I think I am. If I click this once more, identify will stop blinking, and so does the front display panel on my physical Galaxy unit. So I've renamed my Galaxy device successfully, and that means that as far as connection and labeling is concerned, I'm happy. Let's go back to that Overview tab, because that Overview tab on this particular Galaxy, we're currently on My Galaxy, which is an 816 AES3 model, and we're in the Overview tab on that particular Galaxy. This is where you will spend most of your time. And there's a lot to see. Let me take you through it step by step. Okay, the entire block that I'm highlighting over here shows you your 8 inputs. It shows you inputs A through H. There's 8 inputs at all times, regardless whether I have a 408 or an 816 or 816 AES. There are several ways to select those. We'll get back to that later. We can assign them in link groups. But the next thing that you might want to do is input, give them appropriate input labels. So for all I know, input 1 is going to be a left feed. Okay, and this might be a right feed. For all I know, I'm just clicking on those boxes, and giving them names that I feel appropriate. For all we know, we might have a subwoofer send. And for all we know, we might have a dedicated front fill send, and so on and so forth. So this is where we can label our inputs in that section. Okay, so we've labeled our inputs. Over here we have the metering section. And the metering section is what kind of meter is that? Does it show you an average? Is it a peak meter? And that is something that we might want to briefly stand still. And in order for me to demonstrate that, I propose to go back to our inventory, and I'm temporarily going to add a processor by clicking Add Processor, which gives me a dialog. It says you're about to add a processor, and there's 4 to choose from, but we'll save Bluehorn for another day. So let's add another 816, okay, and I can give it a name. I can say, okay, maybe this is my temporary Galaxy. I'm going to click OK. I'm going to use this as a virtual Galaxy, and what happens is that I have a second top, but this is a virtual instance. There's no physical Galaxy device connected to this top. And the only thing that I want to show you that is if I click on Demo, that if we go to the Overview tab of my temporary Galaxy, that we see some meter action. And what I want to show you over here is in the meter section is that meter is a peak meter. It does not show you an average. It's a peak meter that it's updated. top of my head, it's updated 50 times every 50 milliseconds, so it's updated 20 times a second, and it's a peak meter. Also notice that when the meter goes full scale, that very briefly we see a red bounding box appear around the meter. So pay attention in this region, and notice that each time that the meter goes full scale, we temporarily see a bounding box. And that bounding box, which blinks, which is red, informs us that we're clipping. The moment that meter comes within half a decibel of digital full scale or full scale digital, the moment it comes within half a decibel, we will see that red box. There's several options that allows us to change the behavior of that red box, but we'll save that for another day. Just so you understand that this is a peak meter, it does not show you a average. And once you go full scale, a red box will appear informing you that you're in the process of clipping. Okay, that's the only reason that I temporarily needed this Galaxy. I no longer have an application for it, which means that I'm going to disconnect the virtual Galaxy. And by clicking the cross on the left side, I can delete it. Let's go back to the physical Galaxy. Okay, we were still looking at the entire input section, and we've labeled our inputs, and of course we've discussed about the meters just now, and that means what comes next is pretty self-explanatory. I can mute or unmute any of those inputs by clicking on these mute buttons. I can change the input gain of any of these inputs using the keyboard by saying, for example, -5, which will attenuate that input, or +5, where the +5 is mandatory in order for it to be a value larger than 0, or simply 0. That's one way using the keyboard. I can also use this rotary encoder living to the right, and I can turn that and down and up, and that will also allow me to change that level. Furthermore, we can delay our inputs, so we can use again the keyboard by doing 10 milliseconds or 100 milliseconds or even 2 seconds, if you will. 2 seconds of delay, not on the inputs, but on the outputs, yes. So that's where we can delay our inputs, speaks for itself. And again, we can also use that rotary knob living to its right, which allows us to change that delay value as well. Okay, I can do that for one input at a time. I can do that for one input at a time, input A or input B or input C. I could do it one input at a time, but there is a more convenient way to do this, and that is let me kill this for now. That is to do it in the following way. Notice that over here we have these select buttons. And these select buttons, as we already saw during Oscar Barrientos' Compass webinar, which you will find on YouTube, allow me to select multiple inputs at once. So I can select multiple inputs at once. They're all highlighted green, and that means that if I now change delay value, that I will do so on all inputs simultaneously. So that's one way of manipulating multiple channels at once. If I want to zero them out again, all that I have to do is press 0 in that particular box, and then all linked inputs will go to 0 once more. So there's your select option, which allows you to select multiple inputs at once. We're going to look in more detail at that during a later stage. So I've labeled my inputs, and maybe I want to connect these inputs to physical inputs on the back of my Galaxy device. Because in the meter dialog, you can currently see that inputs A and inputs B by default have been assigned to the AES inputs, whereas input C through H has no input at all. So that's maybe the first thing that we want to do after we labeled our inputs. And in order to do that, we're going to go to settings, and rather than going to the network tab, we're going to go to the input and output tab. Again, there's a lot to see here, and many of it is beyond the scope of today's webinar. such as the AVB controller, which applies, as the word implies, to AVB. What we want to do is select our input sources. That is to say, for inputs A through H, we want to assign the physical inputs on the back of the particular Galaxy device. And currently we're looking at my inputs, which is, we can tell from the drop-down menu over here, we're selecting our channels for the 8 inputs. And that means that I can go to input A, and then I go to my drop-down menu, and then I can choose from either an analog input or I can choose the AES input. AVB is currently not configured. We'll discuss that during a different webinar. So suppose that I'm working in an environment where everything is offered analog. Well, then I would simply, are you sure that you want to change? Yes, I would simply change this to analog. Maybe my subwoofer feed is analog, maybe my front fill feed is analog. It could be very well that on a given day I might get an AES feed from a guest console, in which case I would set any of these to AES left and AES right. Galaxy runs at 96 kilohertz. What if my AES signal for whatever reason is 48 kilohertz? Well, no worries. Galaxy supports asynchronous sample rate converters both on the inputs as well as the outputs, so it's perfectly capable of handling different sample rates through its AES inputs. So in this top, the input and output top for this Galaxy, we can connect the physical inputs on the back panel to the inputs A through H. And all of that is reflected over here in the meter dialog. Where it said AES before, you can now see that these 4 channels are all connected to their corresponding analog inputs, and these 2 inputs are now connected to the AES inputs. Inputs G and H still are not connected. So that's how you assign your physical inputs to your inputs of the processed channels, because these channels are all processed. Which brings us to this block. This block will ultimately show whatever processing goes in, takes place within those inputs, and we'll discuss that during a later stage in this webinar. However, everything that we see over here concerns my output, my processed outputs. So the block in the top left are my processed inputs, whereas the block in the bottom are my processed outputs. And there's 16 to choose from. So by design, they've been labeled output 1 through 16, but for all we know, this could be, on a given day, could be mains left. This could be sub left on a given day, and of course we probably will have mains right and sub right on a given day. And there's several ways how you can do it. It would not be misplaced to call this mains right, in which case the next guy would be sub right. However, there might be a more compelling way to do this, because if we temporarily go back to the keynote and we look at one of those Galaxy units, then you will notice that the mute buttons go from 1 through 8, and then the row below it goes from 9 to 16. And that means that if I would make output 1 mains left, output 2 subwoofer right, left, and output 3 mains right, and output 4 sub right, that I would have to press these 4 buttons to mute the system, which is not an insurmountable task. But if your system becomes larger, there is a very compelling reason to make outputs 1 through 8, for example, everything that's left, and outputs 9 through 16, everything that is right, or vice versa, so that you can always press the buttons that live above each other and mute both sides at once. So that's like a little tip for you to label those outputs and connect those outputs the way you see fit. So I'm going to make this output 3 once more, and I'm going to make this output 4 once more, and So an alternative scheme, just for convenience reasons, an alternative scheme would be making output 9 mains right and output 10 sub right, so that on the front panel of my Galaxy device, their mute buttons live on top of each other and not next to each other. So then with 2 fingers I can mute the entire system by just sliding my fingers over the mute buttons. So that's a matter of convenience. So I can label all these outputs, and all those outputs are already by design connected to their physical outputs, their corresponding outputs on the rear panel. So we've labeled our inputs and outputs, we've selected our input sources, we discussed metering, which means that the next thing would be to look at what other features we have in everything that relates to the outputs, which is this entire block. So like our inputs, once we start to apply processing, we will see it in this column. These are plots, and those plots will actually show the curves of whatever processing goes on. The same is true for our inputs. These plots will also show whatever processing goes on in the inputs. Okay, and of course we might have a front fill. Somebody mentioned on the chat we might have front fills, so for all we know these are the front fills left. Allow me to label those FF as in front fills, and for all we know these are the front fills right. For all we know we have stereo feed, or we have enough processing capability to feed those front fills left and right respectively. Okay, so back to the bigger picture. So this is everything related to outputs. Here we see whatever processing goes on in those outputs. The column next to it shows whether any EQ is present in any of those outputs and whether they are enabled or bypassed. So that is something that we see over there. Product integration is a proprietary technique that will make sure that both amplitude and phase curves are matched. For more information on product integration, I defer to the product integration webinar, which we did some while ago, and you'll find it on YouTube. Then there is the option to correct for atmospheric conditions, such as the attenuation of high frequencies. And if it's turned on, or if you want to edit any of those settings, the management of high frequency losses, that's the column where it will show up. All outputs can be polarity normal or polarity reversed. This is just a button. If I click on it, it goes from normal to reversed, and if I click it again, it goes from reversed to normal. Like our inputs, we can delay our outputs, and we can change the gain of our outputs. And we can do that for one channel at a time, or we can do that for a selection of channels, as we're about to discover. Our outputs also have the necessary metering. This is the same metering as we saw on the input. Okay, same peak meter. Red box means that you're within half the beat of hitting full scale of clipping. Of course, we can mute our outputs one at a time, or multiple as one, as we're about to discover. And the selection option that we already saw on the input stage, of course, also applies to the output stage. So I could select multiple outputs as ones and also mute them at once. Very convenient, and there are even more convenient ways to do that. There is one button in this entire panel which is very often overlooked because it's somewhat hard to find, but that's this button. This is the control button, which is super convenient, because if we click the control button, then a window opens up. And this window, let me drag it somewhere where it's not obscuring your view. This window allows me, for example, to toggle all polarity settings. For whatever reason, okay, I need to reverse all polarities. Well, here I can do all at once. Maybe somebody, I don't know, maybe somebody's unplugging a microphone with phantom power applied to it. Well, then I can mute and unmute all my inputs, okay, with a click of a button. I can also toggle the inputs if I decide to do so. Same is true for muting all outputs. Okay, I can mute them, I can unmute them, or I can toggle them. So in panic mode, I really like this dialog, and I can bypass all input equalization and I can enable input equalization, not that any equalization is taking place at this point, and the same is true for my output equalization. So this is a super convenient dialog where I can, just mute everything at once should something be wrong and we're all about to experience a temporary threshold shift. So that's the control button. It lives over there, super important. Okay, let's see. I want to look a little bit at the processing. Well, there's one more thing that we of course should discuss, not entirely unimportant, because we've talked about our input channels, we've talked a little bit about our output channels, but how do I connect those inputs to the outputs? Well, for that, the third block in this overview comes into play, and then I didn't draw the binding box as well as I wanted to. This is everything related to input, this is everything related to output, but this, the summing matrix, this is where we connect the inputs to the outputs. And in order to go there, in order to make the connection between in and outputs, we're going to go to the corresponding top, the top which is lovingly called summing matrix, which lives over here. So in order to make that connection, let's go to summing matrix. Now this is a matrix which has 32 inputs, and the inputs are a column. So everything we see over here, this column, we only see 8 at a time, but that column, those are my physical inputs. Whereas the rows are my physical outputs. So in this row, I have all my outputs, provided I labeled them properly. Output 1, which is my mains left, all the way to output 16. Those are my physical outputs, or AVB, could also be AVB, sent to an AVB stream. And on the left-hand side, we have the column of inputs, starting with input A, which is our left, and then all the way to input H, which is the 8 input. How do I know that I'm looking at my input? Because it currently says that we're looking at the inputs. That being said, I can go to matrix inputs 9 through 16, 70 to 24, 25 to 32, which shows you that the total matrix has a capability of 32 by 16 if you include those AVB channels as well. Okay, let me hide this for now, because how do we connect a physical input to a physical output? Well, it works as the following way. We have to set so-called cross points. So where my left channel, for example, where my left channel, which is this guy, for example, meets mains left, okay, which is this column, over here we have, quite literally, we have a cross point. So if I want to connect the left input to mains left, all that I need to do is click and set a level. If I click on that box, the level defaults to 0, which is unity gain. I might also want to do this with my right input, which lives in this row. And where it meets the right output, which lives in this column, there is another cross point, and that's where I want to connect those two. That's where I want to link them by clicking on that box. So left is now connected to left, right is now connected to right. For all we know, we want to do the same with the subwoofers. Okay, well, the subwoofers live in this row, and where the subwoofer row means the subwoofer columns, which are here and which are here, depending on how you lay out your system, there we have 2 cross points, and at those cross points we might want to link input and output by activating those boxes. Front fills, same story. I'm not going to draw the lines in it, but this is my front fill feed. It needs to go to the front fill left, and for all we know it needs to go to the front fill right, and this is how we connect those inputs to outputs. If for whatever reason our front fills were to come from both left and right, okay, I might want to take -6 by entering -6 from left and -6 from the right hand side, and then I'm summing left and right at -6 meeting -6, and both left and right at those levels will be sent to that front fill loudspeaker or those front fill loudspeakers. So I'm making a mono sum, and the same could be done over here. We're going to spend an entire webinar on matrixing, so rest assured this will be covered in depth. Is there another way? Because currently, if I desire to do so, I can set multiple cross points. If I want, I can send left to the left subwoofer, to the left mains. I can send it to the left front fills. I can send left to mains right and sub right and front fills right as well. Might have no reason to do so, but I could if I wanted to. I can also send multiple inputs to the same loudspeaker. It gets really messy at this point. And if that is something that you would like to avoid, then there's another way to do that, and that is called direct routing. If I click direct routing, then I can make one column meet one row only at one cross point. So now I have to choose either left goes to mains left or right goes to main left. I cannot send both left and right to mains left. Same goes for this situation. I have to, if I want to send my left to mains right for whatever reason, or I want to send right to mains right for whatever reason, then I cannot do both because direct routing has been enabled. Whereas without direct routing, I can send multiple inputs to the same physical outputs if I desire to do so. Very versatile, very versatile. So let's restore this to a more common situation. Left goes to left, subwoofer goes to the subs, right goes to right, subwoofer goes to the right, and front fill goes to both front fills. So there we have the routing of inputs to outputs, and that is being reflected in the overview. So in the overview, we see the same story. In the overview, we see which inputs are connected to what physical outputs. Same story, although in a more concise display style. As of Galaxy devices, we can not only set the level at each cross point, because we have a cross point over here, and we have a cross point over here, and we have a cross point over here, and we have a cross point over here. As of Galaxy, we not only can set level at those cross points, but there is now also the so-called delay matrix, which is the top next to summing matrix. And in the delay matrix, we can also set delay times at each unique cross point. And it's this power that makes it possible to support SpaceMap Go, and all of that can be stored in snapshots and be recalled using, for example, OSC and so on and so forth. We'll talk about that another time, but this is a very, very powerful solution. So there we have our summing and delay matrix, and we briefly looked at the difference between direct routing and not direct routing. Okay, so we've labeled our inputs, we've labeled our outputs, we've assigned physical inputs to the inputs, the processing inputs, and that means that I would now like to look at some processing options. Let's start with the input section first, and that means that if we go to the top, which lives next to overview, then it takes us to input processing. Currently, we're looking at input A. It's red because it's still muted, but we can go to any of the other inputs if we desire to do so. I can do it by using the drop-down menu or by clicking on any of the letters that I see over here to go to those inputs and start applying processing. In this window, we see level or gain on the left side, and we will see phase on the right side in degrees. So this chart will show you both the transfer function, the amplitude portion, so to speak, of your processing, and it will show you the phase response by default. All of that can be hidden, but it will show you those values. Of course, to the left we also have our metering once more that we can monitor over there. And let's see what kind of options we have in this tab. In input processing, it defaults to channel settings, where if I wanted to, I could change the name of my channel once more. I could change the gain. I could add delay. I can change the units if I desire to do so, from milliseconds to feet or any other value. I can mute or unmute that channel if I desire to do so. And I can bypass any EQ, provided it's applied. So what EQ options do we have on our input section? Well, each channel has a 5-band parametric EQ. That's to say each input channel has a 5-band parametric EQ. I can enter values manually. in any of these boxes. I could, for example, do a +6 dB boost. And notice that now we actually see some EQ. The yellow line shows me the magnitude response. That yellow line corresponds to the yellow color of gain that we have over here. But underneath we also see a gray line. Let me try to track that gray line. This gray line that we see over here, that shows you the phase shift that this particular filter introduces. And it's really, really, really cool that what you see in front of you in the graphical user interface is WYSIWYG. What you see is what you get. If you were to measure this using Smart or Sim, if you were to measure a transfer function, then you would get the magnitude response that you see in front of you, and you would get the phase response that you see in front of you, which makes measurement of the processing there's no reason to do that, because what you see in this diagram is what you are going to get. This is what's going on under the hood. This is not an animation. This is not a pictogram. This is the real deal. So we can massage these values using these rotary encoders. Change the center frequency. We can change the bandwidth of our filter, and we can change the amount of boost, and we can do that for each band. I can use the encoders. I can enter the values manually. I can bypass a band. It speaks pretty much for itself. I can bypass it, or I can simply use these handlebars. The red one allows me to change my center frequency. The blue one allows me to drag and click, change the width of the filter, and the yellow bar, which is the color for gain, allows me to attenuate, to boost, or to cut. And notice that all of that responds instantaneously. Okay, so if I don't like this, if this does not represent what I want to do, all that I have to do is right-click anywhere in that window. And if I right-click, a dialog opens, and it says, would you like to reset the parametric EQ? And sure, let's reset this. Are you sure you want to reset the values? And I'm going to say yes, and then it goes back to default, just by right-clicking anywhere in that dialog. Besides parametric EQ, we also have U-shaping, which is our patented proprietary multi-band EQ. We have 5 bands to choose from, where we can change the gain of those bands as we see fit. We can change the frequencies. I'm not going to use the encoders. I'm just going to show you by dragging what goes on. Okay, and then you'll see why I like to think of this as a multi-band EQ. We can change corner frequencies, and this really becomes drawing by numbers. This really becomes very intuitive. Notice that these slopes are all very gentle, but if we want something more extreme, I cannot think of an application. We could change those slopes to higher orders, to steeper slopes, and now you really start to get some really powerful processing. I yet have to discover an application for this particular EQ curve, but that is the U-shaping, which is also featured on the outputs. Again, I don't think that this is a good idea, so let's right-click in the window and say, why don't we reset this EQ? Yes. Okay, so everything is being reset. So there you have your parametric and U-shaping options. I can enable and disable any of that. That goes for parametric as well. It speaks for itself. Okay, I can also do that within the channel settings. I can bypass the parametric, bypass the U-shaping, or bypass any equalization all at once. And you can do that on all your inputs and eat your heart out. Okay. If I wanted to do this for both left and right, there are several ways how we could do this. I could go to my overview and select A and B together, in which case whatever processing applied to A will also happen in B. That would be one way of doing it. I could also make use of the dialog that we see in the bottom right corner, which is there at all times. The section that I just highlighted is there at all times, and that means that I could also select A and B over here. Notice that we get a green bounding box, And that means that if I now decide to boost this band in input A, that it will also happen in input B at once. So that's one way of doing it. And then if you would look at Oscar Barrientos' intermediate, almost advanced webinar, if you will, then you will also see how to do that with link groups. Again, let's reset this and let it be for what it is. Okay, if there is EQ in an input, now we will also see that within our input section. Notice that the EQ that I just applied is now also revealed over here. So now that we actually start applying EQ, notice that both the amplitude response or gain response as well as the phase response appears over there in that input. If I don't want to click on this input processing tab, I can also left click on this diagram, and if I left click on this diagram, boom, it will instantaneously take me to the processing in that input. So let's reset that once more. Yes, and null that out. So there you see your processing besides gain and delay. We have the same functionality in our outputs. In our outputs, we could go either to output processing, which gives us our 16 outputs, which I can select using the drop-down menu, or by just clicking on any of those outputs. Now, what do we have over here? Again, we can change the label, we can change the gain, we can change the delay. We can now also reverse polarity if we decide to do so over here. I'm not going to talk about low mid beam control. But that being said, we have the same parametric filters, but instead of 5 bands, we now have 10 bands. We have the same U-shaping as we saw on the inputs, and we have all pass filters, which is a power tool that we'll save for a different day. Besides parametric and U-shaping, we also have high pass and low pass filters. There's several to choose from, including the legacy filters that were introduced with the original Galileo and could also be found on the Callisto. And then there's the single slope guys such as your Butterworth and Linkridge Riley. We can change the corner frequency of those filters, and we can take them out of bypass. So if I were to change this, for example, into a Linkridge Riley 4th order, then here we see the 4th order high pass filter. Okay, I can drag, left click, I can drag that filter up and down in frequency. I could use the encoder if I decided to do so, or I could directly enter a value for that particular filter. If I don't like it, I can bypass it. If I don't want it, I can reset it, right click in that chart. This time we want to say, okay, reset the high pass filter. Are you sure? Yes, and then it goes back to default. Same is true for low pass filters. There's several low pass filters to choose from. Again, same rationale, left click and drag. Notice that you see both the gain response as well as the phase response. If you don't like it, reset it and take out the low pass filter. Yes. Okay. That takes care of the bulk of the processing. Over here we can also apply atmospheric gain correction, but that is an advanced feature which we'll save for another day. If I don't want the parametric EQ, I can bypass it. If I don't want the U-shaping, I can bypass it. Or if I don't want any EQ whatsoever, I can bypass it all at once. And we can do that for one output, or we can do that for all outputs or a subset of outputs by using those linking options. Now, if I have a reason to do it for all outputs at once, I can also make use of these arrows. Notice that we have this arrow over here, and if I click that arrow, I will select all outputs at once. Boom. And if I click it again, I will deselect all those outputs at once. Boom. Same is true for the inputs. If I have reason to do something at all inputs at once, I can click on that arrow, that green arrow. If I click it, boom, all inputs are selected at once. Boom, all inputs are deselected. Various ways of doing that. So that takes care of our output processing. Now, imagine that you have made something that you're happy with. Okay, you applied some EQ, you've calibrated your system a little bit, and you want to store that as a snapshot which you can recall later. Well, that means that we have to create a snapshot for whatever settings that you're trying to store. And we can do that from the Overview tab by clicking over here where it says Create, because currently we're still using the factory defaults, which we've modified because I've been messing around with Compass, but we're currently still in the factory default snapshot. However, if I've made something that meets my application, all that's left to do is click and a dialog opens and it says you're about to create a new snapshot. So maybe this was post calibration. Okay, I've commissioned the system, this is post calibration, and maybe I want to say that the room temperature at the time was 21 degrees Celsius for whatever reason. Okay, so I'm going to click OK, and notice that over here it now says that the current snapshot that we're using is the snapshot that I just made called post calibration. I can update this snapshot anytime I see fit, or I can make another snapshot. For all we know, we are no longer post calibration, but we are now sound check time. So I'm going to click once more, over there, and I'm going to make another snapshot, and let's call this sound check. Okay, and for all I know, it was 5 p.m. or whatever. Okay, that is where your comments come into place. Okay, so now we have a new snapshot containing everything that you see in front of you, and sooner or later, we might even go into show time. So why don't I create a snapshot and call that show time? Okay, so we've made several snapshots which we can update anytime we see fit, but maybe I want to see what's going on over here. In order to do that, we're going to abandon the Overview tab and we're going to Project. If we go to Project, we see a new window. Starting at the top, it shows us our active snapshot, and it tells you currently you're in the snapshot called Showtime with ID 3. Those IDs can be found in this column, and notice that this column is telling you that we're currently in this snapshot highlighted by the white bar. I can update it. There's all sorts of things that I can do with this snapshot. Maybe it's also prudent to save my work because save early, save often. So that means that I have to save this as a project. So why don't we click Save As, dialog opens and says, okay, save your project file as my project. Okay, and then it tells me that everything we've been doing is living in this project. It shows me also where it lives on my computer, and I will repeat that little piece of information. I will show you that later during this webinar. So now we've also stored our project. Notice that in the snapshot library we see the snapshots that we made. The one that we made post calibration, the one that we made come sound check, and the one that we made come showtime. And I can recall any of those snapshots if I desire to do so by simply clicking on that snapshot and then clicking recall. However, now we have a dialog, and that dialog tells us, careful, you're about to recall a snapshot which might contain different settings. And that means that we have to set certain recall save options, because with the recalling of a snapshot, you might maybe not want to update your input channel types. Okay, maybe that is something that you want to remain persistent. So maybe you want to make that recall safe. That so if you recall a preset, that the physical inputs that have been assigned to your input processing channels are not changed. Same could be said for any AVB settings or clocking information. You can all make that recall safe by saying, and that's the key sentence, I want to exclude this, okay, when I recall. I want to exclude this when I recall a certain snapshot. So that depends on what you want to recall and what you do not want to recall. And there's no way of telling. So I'm going to press OK, and if I press OK, notice that showtime is no longer the current snapshot that we're using. We're now back at soundcheck. If I want to go to post calibration for whatever reason, I will click on post calibration and do recall. I get the same dialog. I'm going to press OK, and now the current snapshot is the post calibration. So for all I know, I want to start every day with post calibration because that is my benchmark. That's my starting point. Well, then it would be sensible to make that snapshot bootable. Now, what do we mean by bootable? It means that when I fire up my Galaxy device after turning it off, if I fire up that Galaxy device the next day, I might want this snapshot to be the one that is automatically recalled upon booting the Galaxy device. And that is very easy. Suppose that post calibration is the snapshot that I want to recall. All that I have to do is click the checkbox, is boot. If I check this box, is boot, notice that there is a B appearing over here in the ID. And that B that lives over here informs me that this is now the snapshot that will be recalled upon rebooting the Galaxy device. So if I have a reason, if it's an installation and I want a specific snapshot to be recalled every day when we fire up the system, that is how you would make a particular snapshot the one that's being recalled upon boot. And that pretty much gives you a first impression of how you can store your settings in snapshots, how you can recall them, being mindful of the recall save options, how you can make a snapshot bootable, and how you can store your projects. Snapshot libraries can also be saved and they can be loaded, and this is of course the appeal of virtual galaxies. Imagine that I'm preparing a show or a session using a virtual galaxy. Then I could go to my inventory. I'm on the bus, okay? I'm on the bus. I want to prepare a session in anticipation of tomorrow's show. I can add a galaxy. It would have to be the same model as the one that I intend to use. So let's say a Galaxy 816. I can use it as a virtual galaxy. And that virtual galaxy, which now lives over here, it also says you're working with a virtual galaxy. I can do anything on that virtual galaxy that I can do on a real galaxy. So I can label my inputs, I can do my matrixing, I can start doing processing. All of that I can do on that virtual galaxy, which I can then store and simply recall in the actual galaxy du jour that I end up using in the field. So I can do all of my homework on the bus prior to a show and save myself a phenomenal amount of work. I can if I have a gazillion snapshots, okay, if I have a gazillion snapshots for whatever reason, I could store all those snapshots as a library and recall it into my active, my physical galaxy and be on my merry way. So those virtual galaxies, they give you a lot of opportunity to do your homework. Okay, I've pretty much covered everything on the list during this introduction. So let's go to that list and make sure that we've discussed all topics. What is Compass? Sure. Register the website? Sure. Download software? Sure. Galaxy devices, audio signal flow, getting connected, window display options, name a Galaxy device, I/O labeling, select your input sources, metering, input signal processing, summing in delay matrix, output signal processing, snapshots, how to recall them and make them certain parameters we call safe, how to make them bootable, store your projects, which means where do all those projects and snapshots live? Well, they live, depending on your operating system, they live in the following folders. For those that use Mac OS, they will live in your home folder, which typically has your username, and then you will find those files, projects, and snapshots in Compass Galaxy settings. And the same is true for Windows, except that Windows does not use a home folder, but it will have a folder named after the username. And then in the same Compass Galaxy settings, you will find your projects and you will find your snapshots. So that is common to both Mac OS and Windows. Finally, something which is really expedient, I'm going to take one more minute to cover that, are are the modifier keys. You might want to take a screenshot of this. This is really convenient, the modifier keys, if you want to work fast and efficiently, because depending on which hotkeys I press, I can do several things at once. So let's look at the first options, muting outputs or inputs in stereo pairs. For this I need to press Shift, Command, and then left click. So let's see how that works. By going to my Galaxy, let's go to Overview, and let's press Shift Command, and notice that with Option Shift, I can mute and unmute stereo pairs. Now the stereo pairs always have to start with odd numbers. If I click on this one, it won't work. So it's only stereo pairs that live on odd numbers. So 1 and 3 and 5 and 7 and 9 and so on and so forth. Same is true for selection. If I want to select 2 inputs at a time, I use the Shift option. Same is true for input. Okay, input selecting, and all of that is very consistently. So that is your selecting in stereo pairs. What else do we have? If we press Shift Command, I made a typo. I did a polarity reversal. Apologies about this. Let me fix this. Okay, on the fly. That is the all, and this is the stereo pairs. Okay, sorry about that. So if I press Shift Command, I can do all outputs at once. So Shift Command, I can mute everything at once. I can select everything at once. And the same is true for inputs and outputs. Okay, so that's very convenient. This also works in the summing matrix. If I want all outputs to look at input 1, all that's left to do is press Shift Command, and then everybody looks at input 1, or everybody looks at input 2, or input 3. Very convenient. Okay, so what other modifier keys do we have? Yes, we can enter values in stereo pairs, and we can do that relative and absolute. So let's look at that. Absolute means that if I want to have a value, let's say as -30, in both output 1 and 2, I just enter the value and then press Shift Enter. And then both those outputs, which is a pair, stereo pair, default to -13. So maybe I want this to be -10. I press Shift Enter, and those outputs become -10. Maybe I want these outputs to become -60, output 9 and 10. I press Shift Enter, and both of them become -60. It could also be that I want all these guys to be 0. Let's try that. There we go. So I've zeroed them out, and you might be wondering, how did he do that? Well, let's look. If I want to affect all outputs, or inputs for that matter, I need to press Shift Command and Option, introduce a value, and print and hit Enter. Okay, let's put that to the test. Maybe I want this to be -10 on all outputs. Shift, Option, Command, Enter, and everybody goes to -10, or 0 if I desire to do so. Very convenient. Okay, we're going to save the relative option for another time. Just make sure that you make a screenshot of this. Very, very convenient, because I don't want to go much longer than this. Okay, we talked about folders and files, and that means that if you want to know more about Compass, we discuss more advanced stuff in the Compass Global view, more intermediate and advanced topics in the Compass Global view, which you will find on YouTube. It will also talk about link groups, as is being asked in the chat, link groups, isolation, all of that is being discussed in that webinar, so please visit the YouTube channel, which I will show in a second. Somebody is asking, can a third-party external controller recall Galaxy presets? Yes, we are. We speak with Creston and solutions like those, so that will work. So for those that want to know more about Compass, either watch this webinar on the YouTube channel or go to the support videos on meyersound.com. YouTube channel is Meyersound's Thinking Sound, where a recording of today's webinar will be uploaded as well. And currently all webinars have been viewed over 11,000 times and rising. Another thing that I would like to bring to your attention is that this Friday we will have the first a la carte on-demand session. And that means that if you go to the Meyer Sound user community on Facebook, that you will find a poll that allows you to vote for either power scaling, M-Noise, or Roskilde Festival. And whatever the majority vote decides will be the topic of this Friday's webinar. So be sure to go to the Meyer Sound user community on Facebook and let us know what you would like us to talk about. Power scaling, M-Noise, or the Roskilde Festival. And that means that we have come to the end of today's webinar. I barely managed to keep it under a little over 1 hour and 50 minutes again, very involved. I'm willing to answer a couple of more questions, 2 or 3 more minutes. Let me stop sharing and turn on my camera once more so that you can properly see me. So I'm looking at the chat, and if you have any questions, make sure that you raise your hand so I know that you're about to ask a question. Well, you're welcome. I see a lot of thank yous. Pleasure. I hope this was an interesting introduction to Compass, and be sure to continue watching us. We have stuff coming up, exciting stuff, exciting topics. We're going to talk. We're going to have a case study this week using Ultra X40s, and then Friday we have the first on-demand a la carte, and then next week is going to be the week of Intelligent DC, where we will talk about the MPSs and where we're going to talk about control pages and groups in Compass. Lots of topics to cover. Can multiple computers simultaneously view a system through Compass? Yes, multiple clients. You can have your Compass Go. You have your Compass all speaking to the same physical galaxy unit, and multiple people can monitor that physical galaxy unit through Compass. AVB networking on Galaxy devices is going to be a standalone webinar because it deserves its own webinar. It's not part of the introduction. Okay, chat is cooling down, which means that on behalf of Meyer Sound, thank you for watching. And tomorrow this webinar will take place in Spanish for those that speak Spanish as well. And Wednesday, I will be back with a case study using Ultra X40s. And Friday, we will have the on-demand and a la carte session. Okay, much appreciated. Stay safe and stay healthy.